This is TMUA question of the day, day 7, with stodmats.com and Tobin Payne. So today our A-level plus category question, relatively simple, just putting together an equation, but just be careful with these. Sometimes the simplest ones are the ones that are easiest to lose marks on. So you've got 3 consecutive even numbers are such that the sum of 4 times the smallest and twice the largest exceeds 3 times the second. So just really think carefully about what's going on there. I'm sorry, I said equation, I should have said inequality. And also, they're asking you for the sum of the digits of the smallest number. So just remember, be careful when you read these questions, because you don't want to get thrown off by giving the answer as what is the smallest number. So, if I was just looking at this or doing any maths, I wonder whether the smallest number is 17, but the answer is 8. Just look out for these things. Right. Very popular with TMUA, introducing notation that you're unfamiliar with, this idea of the integer part and the fractional part. So if you've got equations like this, it's always worth thinking, what would I end up with if I added all 3 equations together? What would I end up with if I subtracted one equation from another one? And remember, you don't necessarily need to find y or x or z. You just need to find what that y curly bracket is, that fractional part of y. And also keep an eye on this. You can rearrange that. So you could say, for example, curly bracket a equals a minus square bracket a. So fractional part equals a minus integer part. And try and convince yourself that the examiner has made this relatively quick if you choose the right combinations of equations to work with. This is a question where it could be very, very difficult if you don't make some assumptions. Now, even looking at this diagram is quite hard, but hopefully you can see that's a hexagon because it's got 6 vertices. And hopefully you can see that all 6 of the sides are equal in length, because they're all going from the midpoint of one edge to the midpoint of an adjacent edge. So if we were to draw, if I call that corner there O, if I was to draw that triangle, we've got OBC. We know OB is a half, OC is a half, and therefore this is root 2 over 2. Just because a hexagon has 6 equal length sides, it doesn't mean it's regular. But actually, we're going to find this really hard if we don't assume that it is regular. And again, it's that kind of leap of faith that an examiner has not made this stupidly difficult or awkward. Can we trust ourselves that that is a regular hexagon? Well, if it wasn't, again, it would be more complicated. So let's just go with it and see what happens. Sometimes you do have to make quick decisions in TMUA in order to move on with questions. Now, these logic questions here about how many statements can be true, ultimately you're looking for contradictions. And a lot of these logic questions in TMUA and the like are about contradictions. Now, usually they can't all be true, not guaranteeing that that will happen, but most of the time there's at least one which contradicts others. We've got a load of inequalities here, in fact all inequalities. So remember, if you divide or multiply an inequality by a negative number, you're going to have to switch around the inequality. So think about which ones are definitely not going to contradict each other completely. So we can see, obviously these two are not going to contradict. And then try and build up from there. Can you see a pair that do contradict each other? If you can, then you can write off 5 straight away. Can you 5, 4. Usually with these, start off assuming that it could be 5, find a reason why it's not, then try and find a reason why it's not 4. If you can't find one, then the answer is almost certainly 4. Okay, thank you for watching. Any feedback, as always, appreciated.